Okay, today we start working with right triangle trigonometry, and most of today is going to be the basics, but it's also going to be some very important basic stuff. Most of trigonometry, as I told you, deals with right triangles. So let's draw a right triangle. Right triangle obviously is one where one of the angles is a 90-degree angle. And one of the things that we have to do right away is get used to this letter theta. Theta represents an angle. So if that is my angle theta, okay, then this side directly across from it is what we call the opposite side. And the side that is attached to this angle, that is not the hypotenuse, is the adjacent side. The hypotenuse is always the side opposite the right angle. It's always the longest side of a right triangle. Now, in geometry, you remember hearing about Sohcahtoa. What does that mean? Let's review that. Sohcahtoa means, for this first part, so that means the sine of theta is equal to the opposite side over the hypotenuse. Okay, the sine of an angle, now we have to be talking about a right triangle. The sine of an angle is equal to the opposite side divided by the hypotenuse. This, by the way, this sine is actually a function. We will learn to graph them later. We'll spend a lot of time graphing them later. And it is a function. So when you put something into this function, if you remember us talking about the function machine, what do you put into a sine function? You put an angle. Okay? So if I want to evaluate the function, I have to put in an angle, whether it is in radians or degrees. So what does the CAH stand for? It stands for the cosine of theta, and that equals adjacent over hypotenuse. And then TOA is the tangent of the angle theta, and that is opposite over adjacent. Now, you need to know that there are partners to these, and this is maybe something that you did not learn in geometry. Each of these functions have what I call a brother function. All right? They're actually, their proper name is the reciprocal functions. And they're called the reciprocal functions because their value is just the reciprocal of this. All right? So, for example, the reciprocal of opposite over hypotenuse is hypotenuse over opposite. Well, what is the name of that function? It is the cosecant. And we abbreviate it with the CSC. Cosecant is the way you say that. Cosecant. But we just write CSC, cosecant of theta, equals the flip of sine. As a matter of fact, we can even say that cosecant of theta is 1 over the sine of theta. All right? All three of those relationships are important for cosecant. All right? And then we can do the same thing for cosine, only it is called just secant of theta. and it is the reciprocal. Instead of adjacent over hypotenuse, it's going to be hypotenuse over adjacent. And of course, it is the same thing as 1 over cosine. And then the reciprocal for tangent is what we call cotangent. And we abbreviate it with COT. No, we don't say cot. It stands for cotangent. All right? The cotangent of theta, we flip this and it will be adjacent over, opposite. I don't know why I wrote hypotenuse. Instead of opposite over adjacent, it's adjacent over opposite. And cotangent is the same thing as the reciprocal of 1 over tangent. Those are what we call the 6 fundamental trig functions. All right? These 3, I'm sure you are more familiar with. The other 3 might be a little bit newer. All right? So, tonight you're going to have some problems like this. Find the exact values of the 6 trig functions of theta. This will be very easy for the most part. They're going to give you a right triangle. They're going to give you an angle theta, and they're going to give you a couple of lengths of the sides. Maybe they'll give you 3 and 4, like that. Now, if they only give you 2, how can you find the third? Pythagorean theorem, okay? So remember that Pythagorean theorem says that a squared plus b squared equals c squared. If you have to find the third side, you may have to use that. And we want to keep, by the way, we like to use radicals instead of decimals when we're doing this. Now, I can tell you right now that this third side is 5. This is one of those other special right triangles. We call it a 3, 4, 5 right triangle. So we could have used Pythagoras, but that's one that we kind of know. So if I want to do the 6, the 6 trig functions of theta, the sine of theta is opposite over hypotenuse. I just put O over H, all right? So, and we don't have to write that on all of these. I'm just doing it for the first one to explain. So the sine of theta is the opposite side, which is 4, over the hypotenuse, which is 5. And we've done that one. So now let's go to cosine of theta. The cosine of theta is equal to the adjacent side to that angle over the hypotenuse. So it's 3/5. The tangent of theta is opposite over adjacent. So it is 4 over 3. Notice it's all in relation to where that angle theta is. If theta would have been up here, those values would have been different. All right? But it's not. So let's keep going. We need to do the other 3, the reciprocal functions. So the reciprocal of sine is cosecant of theta, and if we just flip it, it's 5/4. The reciprocal of cosine is secant, and we just flip it, and it is 5/3. And the reciprocal of tangent is cotangent, and that would be 3/4. Okay? Now, one of the most important things that we need to get from today is what I would call the memorized values. And we're going to spend more time with these later. The good news is you don't really have to memorize them if you can draw the triangle. Okay? So, what am I talking about? I'm talking about, remember those special right triangles that we did? the 30, 60, 90. There's 30, there's 60. And we did a little bit of work learning how to find those sides. We said that this side was 1, this side was 2, and this side was radical 3, like that, right? Well, if I know that, these are some of the most common angles used, all right, in trigonometry. And remember that 30 degrees is the same thing as pi over 6 radians, okay? So the sine of 30 degrees would be the same thing as the sine of pi over 6, okay, in radians. So if I know this, all right, then I can just do this. The sine of 30 degrees equals what? Isn't it 1/2? The sine of 30 degrees is 1/2. Very common value that we're going to use a lot. The cosine of 30 degrees is radical 3 over 2. The tangent of 30 degrees is 1 over radical 3. All based on this triangle up here. Now this last one for tangent, we normally rationalize. We normally rationalize this. So I'd multiply by radical 3 over radical 3. So we normally say the tangent of 30 degrees is radical 3 over 3. That's the value we normally use, is radical 3 over 3. Okay? Now, I'm not going to do the reciprocal functions right now. I'd rather go to the 60-degree angle. What if I were to do the sine of 60? It's going to be a different value, isn't it? What's the opposite side from the 60-degree angle? Radical 3. So that if it's 60, the sine of 60 is radical 3 over 2. And the cosine of 60 is 1/2. And the tangent of 60 is radical 3 over 1, so we can just say radical 3. Now, what I'd like for you to do now is go back and add above each one of these what we use for radians. 30 degrees we call pi sixth, and 60 degrees we call pi thirds. Same thing for all of these. This would be the same thing as pi sixth, pi sixth. These over here are pi thirds. The reason I write that is because you need to know that if you do the sine, cosine, or tangent of the radian angle, you get the same value. Okay? So if I were to do the sine, like looking at this one, I could also say the sine of pi sixth equals 1/2. Okay? I can say the same thing using the radian measure of that angle. Now there's another right triangle we learned, the 45, 90. And we said that those two legs were 1 and the hypotenuse was radical 2. So if I do the trig functions of this one, the sine of 45 degrees is the opposite side, which is 1 over radical 2. But we have to rationalize that. So we would say that the sine of 45 degrees is radical 2 over 2 after we rationalize it. Now, isn't the cosine of 45 degrees going to be the same thing? The cosine of 45 degrees, because my opposite side and my adjacent side are the same, it's going to be the same thing. It's also going to be radical 2 over 2. All right? And the tangent of 45 degrees is opposite over adjacent, so it's just going to be 1. Okay? So these three values are also very important. And those are values that if you forget them, you can always draw the triangle and refresh your memory. Okay? Now, tonight, you're going to have a few problems like this, where they tell you to solve for x. Okay, this will not be very difficult. They're going to give you a right triangle. They're going to say, okay, this is 40 degrees, this is 30, and this is x. Okay? So they want to know what the length of the hypotenuse is. Well, one thing I know, if it's a right triangle, if I have an angle and a side, I can find the rest. So what you have to decide is which trig function to use. So I have an angle. Which side is that in relation to the angle? Is it opposite, adjacent, or hypotenuse? Okay, this is the opposite side. All right, and I'm trying to find the hypotenuse. So which trig function relates the opposite side to the hypotenuse? Isn't it sine? Okay, the sine of theta equals the opposite side over the hypotenuse. That's the one that I need to use. And then we just fill in the blanks. I know the angle, so I put the angle in for theta. The sine of 40 degrees equals the opposite side, which is 30, over the hypotenuse, which is x. And now I just have basic algebra. 40 degrees is not one of those common special triangles. So this means we need to use the calculator. Now, first things first, you better go to your mode and make sure you're in the correct mode. I am not in the correct mode. I am in radian mode, and I'm going to be plugging in a degree angle. This is something that people forget all the time. You have to be in the correct mode with the calculator. So I'm going to switch it to degree mode. And now I'm ready to use it. So I need to find the sine of 40 degrees. So I put the sine of 40, put my other parentheses, and hit enter. There it is, 0.643. So now I'm ready to solve this algebra equation. This is 0.643 equals 30 over x. Now it's just basic algebra. I'm going to multiply both sides by x. These x's cancel. I have 0.643x equals 30. Divide both sides by 0.643. Okay? And 30 divided by 0.643. 30 divided by, I'm going to use the answer button, is 46.7. So this hypotenuse right here is 46.7. Now, just to try to help you a little bit, wouldn't I know that I did something wrong if this hypotenuse was shorter than this leg? Okay? That's a good way to check your work. All right? So you will just have to pick the correct function, whether it's sine, cosine, or tangent, to use. Tonight, you'll also be asked to just evaluate with the calculator, like find the sine of 12 degrees. Well, that is not a common value, so you're going to use the calculator. All right? So I would do the sine of 12 degrees. I'm already in degree mode. So there I have it, 0.207. Okay, that's easy enough. But what if they give you this? the cosine of 4.6. And I do not see a degree symbol. If you do not see a degree symbol, then this is radians. And when you do this on your calculator, you have to switch your mode. So I do that first. I switch my mode to radians, and then I do my calculation, the cosine of 4.6. Okay, negative 0.112. We'll talk about why those are negative later, negative 0.112. Now, what if you get one of the reciprocal functions, like the cotangent of 39.7 degrees? There is not a cotangent button, and no, you cannot use second tangent. Second tangent is not what you do, all right? So do not use, you might want to make yourself a note, do not use second tangent. Okay? That is wrong. What we have to use is the fact that this is 1 divided by the tangent of 39.7 degrees. And that is how you have to enter it in your calculator, and make sure you put your denominator all in parentheses. So the correct way, first I need to be in degree mode. Keep flipping back and forth, but that's just the way it goes sometimes. Degree mode. So I'm going to do 1 divided by the quantity tangent of 39.7, parentheses for the angle, parentheses for the quantity. Hit enter. That is the correct answer, 1.20. Okay. One more thing, and that is if they ask you to find the angle, find theta. Let's say they give you the sine of theta equals 0.789. This is where you use second sine. All right? So if I want to find theta on my calculator, I'm going to use second sine of 0.789. Now, you better know which mode you're in before you start, because that's the answer you're going to get. All right? So, which mode am I in? I'm in degree mode, so my answer will be in degrees. So, I will do second sine of 0.789 and hit enter. So that angle is 52.1 degrees. What if I wanted to get the angle in radian mode, or in radians? Then I would have to switch my mode to radians first. Okay, so now I'm going to do second sine of 0.789 and hit enter, and you'll see I get a different answer. That's because that's the measurement in radians, not degrees. Remember, radians are measuring the arc length of the angle it intercepts. So 52.1 and 0.91 are my answers. 52.1 degrees and 0.91 radians. I think your book actually asks you to find the answer in both degrees and radians, so you need to know how to do that. We are going to stop there for today.